Hi guys, I'm in the engine room and I'm going to check how many amps my starter engine is receiving from my batteries. So I have borrowed a CCA meter, cold cracking amp meter, which will tell me how many amps is available to pull from a battery, or indeed any point in an electrical system at any given time. So I have now connected this to my batteries, directly to the batteries, and it gives me a reading of 1139 amps that is available for me to pull from the battery terminals. But when I move these ones onwards to the main engine switches, these are the main switches for the engine, I get a reading of 733. So this is only what we are losing in these 70 square millimeter cables going from the battery over here. We have lost 400 amps. Now if I move these to the other side of the switches, I get not 700 but 664 amps to potentially pull in this position. 664 amps. And then I move these down to the very starter engine to see how much can I pull, how much power does the starter engine receive, and the rating is 482 amps. So 482 amps is of course great. I will not have any problem starting my engine with that kind of power. But before I renovated these main switches, I only got 78 amps. So that was a bit close to the too close to the specs. So if you need to research the cables to your generator, you measure from B+ to ground on the generator, and we get a reading of 226, and that's great because this is a 120 amp generator. So I don't have a problem here, but I'm now going to go ahead and check how much power does my windlass get and other things in the boat. And here are the main switches for the windlass, minus and plus. We don't want any connection from the minus to the hull of the steel boat. And then cables are running way over here and to this relay. And when measuring on this relay, we find that 105 CCA, a maximum of 105 amps, can be pulled by this relay. And that is actually fine, because the fuse needs to be 100 amps, and so it all fits. But I'm very happy that I used these cables of 70 square millimeters, because if I had gone down in dimension, we would have received a lesser value. So that's how you can use this kind of a meter. So I found this switch, this power switch, which is minus for the windlass, has an unusually high drop in CCA. So this windlass will not pull more than maximum 100 amps, but still this is a significant drop. Okay. Significant drop. Okay, yeah. You can also check with a standard voltage meter. So right now we're not pulling any amps. Here are the amps that's being pulled through the switch. So it's 0, okay? And if we check the voltage over the switch, it is 0. We are not losing any voltage over this switch, but when I start the windlass, we are losing 0.15 when running a power of 53 amps. we're losing 0.15 voltage over this switch. So if you're researching a problem, you can look for heat. You can measure how hot it's getting. It's hardly noticeable, but a little bit, a tad warm. And you can also check with the voltage meter how much power are you losing over different switches, over the fuse. We can measure the fuse as well. How much are we losing over this fuse? .17 volts over this fuse. So we're losing voltage all the way through. But still, this is an operational system. If you were having problems, this would be much more significant. It would be higher values. Good luck.